Hello guys, welcome back to the channel. This is Rosario Borgesi, and in this video we will discuss Uniswap, how it works and how it allows us to perform token swaps on Ethereum layer 1 and also layer 2. We will also discuss how to integrate Uniswap inside our application. So let's get started. So this is the Uniswap web page. Swap a token into another means, as you can guess, to exchange one token with another. For example, I can swap Ethereum, Ether for USDC. Here it goes by default on the mainnet. I can connect my MetaMask wallet. Okay. Okay, I'm in the mainnet, Ethereum mainnet. So this is Ethereum mainnet. I can swap, for example, 0.001 into USDC. Okay. This is the amount of token of USDC token that I will get from this trade. And as you can see here, it will cost approximately $10. So the cost is very, very high to perform these operations on the Ethereum mainnet. We could also perform this operation on layer 2, as we will see, but we can exchange any type of token, all the tokens that are listed here. For example, Tether USDT, Wrapped Ether, USD coin, whatever it is listed here. And for example, if you want to perform this operation on base, we can select here, we can change the network, which is choose the base mainnet, base layer 2, base Ethereum, and we want to exchange it in USDC. As you can see, this is a very low amount of also here the gas fee are significantly lower, almost 10 times lower. So here I change the network, I go to base mainnet. Okay, I select review. Okay, swap. Okay, base mainnet. You send this amount of Ethereum in USDC. The fee is this one, confirm. Okay, the transaction has been confirmed. So here I should see. Okay, here it recognizes that there is a new type of token on this network. I import it. Okay, I have this small amount of token, so the transaction has been done. You could also swap from one chain to another. For example, here I am on base. I select 0.001 Ether. I can make a bridge to, for example, Ether on Optimism, which is another layer 2. Maybe I should put a higher amount of token. For example, you could also perform that. As you can see, also here the transaction fees are significantly lower than the Ethereum mainnet. So this is how Uniswap works. I would like now to point out what are the main characteristics, the main features of Uniswap. Just briefly, I would like to discuss that. Okay. Now, this is the here I have highlighted the text that is important. So Uniswap is a peer-to-peer system because it it works on blockchain, so it is peer-to-peer system designed for exchanging cryptocurrencies like ERC20s. All these tokens you have seen, USDC, USDT, or also Ether. Ether gets converted to another to an ERC20 token, which is a wrapper called wrapped Ether. You can find all these tokens on CoinMarketCap. This is a good website where you see all the token listed, and you can see the price, the market cap, the volume, the supply chain. So apart from Ether, which is the currency of the chain, and it is not an ERC20 token, all these Tether, USDC, for example, also Chainlink, these are all ERC20 tokens, so they are smart contract. It is not the native currency of the chain. And as I was saying, so this is a Uniswap protocol is a peer-to-peer system designed for exchanging cryptocurrencies, so ERC20 tokens on the Ethereum blockchain. Also, Ethereum blockchain, it is intended also layer 2s like Base Mainnet, Optimism, Arbitrum, and so on. The protocol is implemented as a set of persistent and non-upgradable smart contracts. So it is a set of smart contracts deployed on the chain that allow us to perform these swaps, and is designed to prioritize censorship resistant security, self-custody, and function without any trusted intermediaries who may selectively restrict access. This means that when we use a broker, for example interactive broker, there is a central authority which governs the exchange between the trade, while here the process is governed by smart contract, so there is not a central intermediary that acts to perform this trade. So it is important that the main innovation that brings Uniswap is this, that while most publicly accessible markets use a central limit order book style of exchange, where buyers and sellers create orders organized by price level that are progressively filled as demand shift. This means that there is a central authority with an order book, like in the typical brokers, for anyone who trades stocks. There is an order book where there is someone who wants to buy some shares of stock, another who wants to sell some shares of stocks, and with this by matching the offer and the demands, it is determined the price. While here there is not an order book, so there are not people that wants to sell a stock, for example a token, for a determined price, and other people that wants to buy it for a specific price. There are instead here there is an autonomous market maker, so that replace implemented with the smart contract that replace buy and sell orders in an order book market with the liquidity pool of two assets, so which are relative to each other. What are these liquidity pools? You can see them here. No, it is here. So there is a couple, as you can see, USDC versus Ether, and here this is a pool, so it is a couple of tokens. You can exchange one token for another, and there are various fees. These are the fees that you will pay to there are different levels of fees that you will pay to Uniswap. For example, here is 0.05%, here 0.3%. For each couple there are this different type of fees. And so these two, in a liquidity pool, there are two assets, both valued relative to each other. So as one asset is traded for the other, the relative prices of the two assets shifts, and the new market rate for both is determined. In this dynamic, a buyer or seller trades directly with the pool rather than with specific orders by other parties. So there are not orders, but you trade specifically with this with the pool that we have seen here. So another thing that I would like to point out is that in the previous there are various versions of Uniswap protocol. For example, in the version 2 there were price intervals that ranged between 0 and infinite, while in this case with the version 3 of the protocol, the liquidity providers concentrate their capital to smaller price intervals. For example, in a stablecoin pair, a liquidity pool may choose to allocate the capital solely in the range 0.99-1.01. This because, as you can understand, since a stablecoin is exchanged mostly in this range, in the other range the people that allocate this liquidity, if there are no trades outside this or significantly lower trades outside this range, they don't get any fee, they don't get paid, so they can restringe the range and to this range here, and so they collect more fees, and it is more efficient because otherwise there would be some capital that is never used, and so it will be worthless. So in the previous versions, the price intervals stretched from 0 to infinite. Now you have the price range, so you can allocate more capital in the most used range, and so prevent that some capital goes unused. So that's it for the intro for Uniswap. Now let's see how to add this functionality, how we can add the Uniswap functionality, the possibility to swap token inside our applications. And in this case it helps us this very very good article done by QuickNode. So here it explains the main smart contracts of Uniswap. So for example, Uniswap V3 factory that deploys new pools and keeps track of all existing pools. Uniswap V3 pools that handles the core functionalities of swap, liquidity provision, and fee collection within a specific pool. Then we have these were the core contracts. These are the periphery contracts, so higher level contracts that interact with the core contracts to provide helper functionality and easier interaction. So it is a set of contracts that include the swap router that provides an interface for performing swap with advanced features like multi-call support, non-fungible position manager, which manages the creation and management of liquidity positions represented by NFTs, and the water contract that helps us get swap quotes without executing the swap. We will use this contract in the code. This you can check, you can use it, but you can use whatever node endpoint to RPC node to execute this operation. I will skip this, so let's go into the project. Here there is this is the repository GitHub where they have placed the code. So no, the code is this one. The code that we will use is this one. You just need to do git clone, change directory to DeFi / Uniswap V3 swaps, and then execute npm install. So once you have done the git clone and npm install, you should have a project like this. You have to put here you have to create a .m file with RPC URL and that can be Infura, whatever, also QuickNode, whatever you want. Here you put the private key. So these they should always be kept private. So once you have done this, this is the main file here. So you have the index.js. Here we should change assert with the width, otherwise it won't work. Okay. Here you have the address of the Uniswap smart contract, full factory, quarter, swap router. These are the Sepolia address. You could also test it also on other chains, but you have to change this address here. Also, this is the address of the wrapped Ether token, also on Sepolia. And this is the address of the USDC token, also on Sepolia. As you can see, this is the chain ID, is the ID of Sepolia. So here it explains the code. So it says that regardless of the token we are swapping, we have to give to the swap router contract the approval to send our tokens for us, and this function here, approve token, creates an approval transaction payload. And sends, so creates this approval transaction payload with this function here, populate transaction, and then sends the transaction with signer.send transaction here. With this here it sends the transaction. This is Ether.js code. Then with this other function, get pool info, it get the pool details. So the swap we are making is from wrapped Ether and USDC. Wrapped Ether is basically an ERC20 token that represents Ether, because Uniswap works with the ERC20 and cannot work directly with the Ether with Ethers. And so in this code is trying to get the pool function, is trying to call the get pool function on the factory contract to get the pool, and this will return a pool address based on 3 parameters: token in. Here we are calling the smart contract function get pull. So we are providing token in, token out, and the gas fee. The gas fee level, it is there are various range. There are various range that are explained on the Uniswap documentation. So once it has retrieved this pull address, the smart contract address that we must call, then we can create another headers contract instance and initialize the pull metadata variables. So the contract instance, it is this one. As you can see, it is passing the address that it is retrieved from the get pull method. Then it is passing this API that you can find here. It should be this one, pull.json. We can also see with in the code, so it is get pull info, get pull info. Okay, the API is this one, pull API. Okay, it's pull.json, the file that we have seen earlier, and it is also providing the provider. This should be the provider should be who signed our wallet that signs the transaction. Okay, so in fact here we are no, it is the URL node. Get RPC provider, it takes the RPC URL, so it is the node. Okay, here it creates a contract instance, and then it executes these 3 promises to get token 0, token 1, and the fee. Okay, and returns this information. Then it will fetch the quote. Uniswap has implemented a quoter contract to obtain trade quotes. We need to obtain the quote to execute the swap. So we will use this contract to determine the expected output amount for our trade without executing it. So the quote exact input single method is one of 4 available methods in the quoter contract. It provides a quote for the output amount for a swap in a single pool, given the input amount you want to swap. So basically we are calling this contract this method of the quoter contract to get how much token output we can get from the token input that we want to swap for this particular quote that we have retrieved. And here is calling the call static method offered by the library Ether.js to submit a state changing transaction to the Ethereum node, but the Ethereum node should simulate the state change locally rather than executing it. So the purpose of this method is not meant to be called on chain. So we are not calling the method on chain, but we are simulating this call here with this static call here. So we are providing token in, wrapped Ether, token out USDC, the fee, the recipient, signer.address, it is our address for which we have provided the private key, deadline, the amount in, and this is a parameter. This is a specific parameter of Uniswap that we are setting to 0. Okay, then we will create a swap transaction. So once we got the quote, we can start to create the swap transaction. So the prepare swap params function is designed to set up the parameters needed for a token swap. The function takes in the pull contract distance here, the signer, and amount in the input and output tokens. So here takes the amount of token that we want to exchange. No, sorry. No, right. The amount of input tokens, amount in, and the minimum amount of output expected tokens, amount out. So this is actually the minimum amount of output tokens expected, while amount in is the amount of input token. Okay. Then this function, of course, here we are also populating the transaction parameters, and then we are sending the transaction. Okay, so the execute swap function populates a transaction with the given parameters using the exact input single method that we have discussed earlier of the swap router. It sends the transaction using the signer, which handles the transaction signing and sending. After the transaction is sent, it logs the receipt URL on Etherscan. So here in the main method, we are executing all the steps that we have discussed before. So we are creating a main function that takes in an input amount in Ether, which are wrapped Ether, 0.001 for example, and calls this main function the steps that we have covered in sequence. So number 1, gather pool details, fetch the quote. Number 2, number 3, create the swap payload. Number 4, send swap transaction. They are executing all here, and here then you can see the swap gets executed. So we have everything here. So we could just, for example, so we should change directory to DeFi / Uniswap. Okay. Then if we want to execute, this is my account, we are in Sepolia. Let's see what I have in my wallet. Sepolia testnet. Okay. I have set this account here to execute where the transaction that we received the amount of USDC. As you can see here, I already have a certain amount of wrapped ethers. Okay, and so I can perform this operation. But if I didn't have this wrapped ether here, I could not perform this operation, and I needed to swap an amount of Sepolia ethers into wrapped ethers, and then we can execute the operation of swapping between wrapped ethers to USDC, because as we said earlier, Uniswap does not work on Ether, but it works on wrapped ethers. So to wrap Ether into wrapped ethers, I can call this function. I need maybe to change some parameters. This is already have it. Okay, fine. WETH contract address. We can make this change here. WETH contract address, it is this one. Okay, here I put the const. Okay, WETH contract address goes here. Okay, now we should be fine. This could be also const USDC contract address. Okay, so I can put this constant here, and this is the chain ID, so I can do also this. Okay, the chain ID goes here, 1 and 2. Okay, so this is our wrap function. I have added some logs here. I added the transaction weight. Basically here we are printing the hash. We will check it then in the scan, in the network scan. So basically this function is calling the deposit function of the wrap it contract, which is an ERC20, so it must have the deposit function along with the transfer, approve, and so on. If you are new to ERC20 tokens, please check out my video in my channel, and we can execute this transaction. We just need to type node. Okay, so this is the hash of the transaction. Now it is waiting for the transaction to be confirmed. Okay, so as you can see, this is the hash of the transaction. We are executing a transaction from my account, which is this one, to this. This is the account of the Ether token, ERC20. Since we are depositing Ether, we are also providing a value, and we can check the transaction here. This is the hash. We can go to Sevolia Ether scan and check this transaction. Okay, transaction okay. From my account to this is the account of as you can see, wrapped Ether token ERC20. The state tells us that here there is an increase of the of this amount of token, which is the one that we have provided here. Okay, and we can also check out the wrapped Ether address here. As you can see, sorry, this is my, this I don't know why it does not find my account. This should be my account where I have deposited the fee, this amount of Ether. It is the same, 368. Okay, I don't know why it does not find him from here. Maybe because there are these dots here. Okay, so the transaction has been performed. So here now I should see, I can see a higher amount of wrapped Ethers. Since I have this amount of wrapped Ether, I can perform the swap between wrapped Ethers to USDC, and I uncomment this, comment this one, and I execute another time node index.js. Firstly, it execute the approval transaction. Now, okay, then it has fetched the quote. The swap, of course, will result in this amount of USDC. We can check the transaction here. We wait for it to be confirmed. Okay, so as you can see, the transaction starts from my account. This is the account of the I close this. This is the account of the swap router contract, which is performing the swap. And so we can say that from this is my account. This other account here is the wrapped Ether contract. Okay, so basically it is telling us that for this amount of wrapped Ethers, ERC20 wrapped Ethers, we are obtaining this amount of USDC in output. Here maybe it tells us more informations. No, it gives us only the reference to the smart account. Sorry. So the transaction has been performed. Here we should find 24 more tokens. Now, if you like, you can try also on another chain. You should change the address of these tokens here. For example, but you should be. For example, I have tried it on Base Evolia, but there are problems related with liquidity. So, for example, the quotes in output for wrapped it to USDC is 0. But I have tried it also on Unichain, and it works. But of course you have to change all the address of the smart contract because they will be different. And of course you have to change the chain ID, and you have to change in the M file the RPCR URL. So we have reached the end of the video. I hope that it has been useful. If you have any questions, please drop a comment and I will reply to you as soon as I can. Thank you for watching and see you in the next video.